video, I am going to explain you the topic of AC circuit consisting of pure inductor only. Consider an AC circuit consisting of an inductor of L Henry. It is given supply by using voltage of V volts. V is equal to Vm sin omega t. It is an alternating voltage, due to which an alternating current of I amperes starts flowing in this circuit. This is an inductor, and in this inductor, according to Faraday's law of electromagnetic induction, EMF is induced. This EMF is given by equation E is equal to minus L di by dt. As per Lenz's law, this EMF opposes the cause producing it, which is nothing but the change in the current taking place in the inductor. So, in turn, this EMF opposes the applied voltage. Thus, V is given equal to plus L di by dt. Separating the terms, we can write di is equal to 1 upon L V dt. We know that V is equal to Vm sin omega t. So, substituting this equation of V in this, we get di is equal to 1 upon L Vm sin omega t dt. Integrating this equation, we will get the value of I. So, integration of di is equal to integration of 1 upon L Vm sin omega t dt. Vm is a constant, L is a constant. So, we get I is equal to Vm upon omega L minus cos omega t. This minus cos omega t can also be written as sin of omega t minus pi by 2. So, I is equal to Vm upon XL sin omega t minus pi by 2, where XL is equal to omega L. So, I is equal to Im sin omega t minus pi by 2. Here, Im is equal to Vm upon omega L. This is equal to Vm upon XL, as XL is equal to omega L. If we divide this equation by root 2, we get I is equal to V upon XL, where I and V are the RMS values of voltage and current in this circuit. Here XL is equal to omega L is equal to 2 pi FL. This is the total opposition because of this pure inductor in the circuit. Now here we have got two equations. One is V is equal to Vm sin omega t and I is equal to Im sin omega t minus pi by 2. Both are alternating quantities. If we plot these alternating quantities against theta, we get the graphical representation of voltage and current. These are two sinusoidal waveforms. Here we observe that voltage is 0 as theta equal to 0, but current is 0 after pi by 2 radians. That means the current is lagging behind voltage by pi by 2 radians. This is also shown in the phasor diagram, where voltage is taken as reference and current is shown lagging behind the voltage by 90 degrees. The phase difference between voltage and current is pi by 2 radians, and hence the power factor of the circuit cos phi is equal to 0. In this video, I am going to explain you the derivation for instantaneous and average value of power delivered to the pure inductor. Let us see the waveform of voltage and current. At theta equal to 0, it can be observed that the voltage is 0, current is negative maximum. So, the product of voltage and current, that is power, is equal to 0 at this instant. Again at pi by 2, current is 0, voltage is positive maximum, but the product will be 0. So, power supplied to the inductor will be 0. Same thing is going to happen at pi, 3 pi by 2 and 2 pi, where either voltage or current is 0 and hence the product, that is power, is 0. Between 0 to pi by 2, voltage is positive but current is negative. So, the product is negative, power is negative. Between pi by 2 to pi, voltage and current both are positive. So, the product, that is power, is positive. Between pi to 3 pi by 2, voltage is negative but current is positive. Again, the product is negative. Between 3 pi by 2 to 2 pi, the product is positive. as both current and voltage are negative. So it can be observed that for half cycle duration the power is positive and for remaining half cycle duration the power is negative. Positive power means the power is supplied from source to load, that is to the inductor, whereas negative power means the power is supplied from inductor to the source. Now let us see the mathematical expression for instantaneous power. P instantaneous is equal to the product of instantaneous voltage and instantaneous current. If we substitute the expression for instantaneous value of voltage and current in this, we can write P instantaneous is equal to Vm sin omega t into Im sin omega t minus pi by 2. Im sin omega t minus pi by 2 can be written as minus cos omega t. So the expression becomes minus Vm Im sin omega t into cos omega t. Sin omega t into cos omega t can be written as sin of 2 omega t upon 2. This is a double frequency term. If we integrate this expression of instantaneous power over full cycle duration in order to find out P average, the integration will become equal to 0 because it has a double frequency component. This means that the average power which is supplied to the inductor over full cycle is equal to 0. So inductor is a device which accepts power and gives it back to the supply. It doesn't consume power.